All right, so you've tried this practice problem. It's kind of a unique one in that we have a relative velocity of a bullet relative to the tank, but the tank's moving relative to the ground. So we have a relative velocity. We also have projectile motion. We also have simultaneous motion. Cool problem. There's many unique ways to solve this, and I'm always impressed with how many ways you guys come up with to solve this. So I'm just going to go through one way here and explain to you how I went ahead and solved it here. So let me read the question for you just so we're all on the same page. Two tanks are engaged in a training exercise on a level ground. The first tank fires a paint-filled training round with a speed of 250 meters per second at 10 degrees above the horizontal while advancing toward the second tank at a speed of 15 meters per second relative to the ground. The second tank is retreating at 35 meters per second relative to the ground, but is hit by the shell. You can ignore air resistance and assume the shell hits at the same height above the ground from which it was fired. Find the distance between the tanks when the round was first fired, which I called x1, and at the time of impact, which I called that distance x2. All right, so here's my goal. This is my strategy. So first, because it's projectile motion, I know the vertical component, and I know it's going to start and end at the same height. So I should be able to find the time that it's in the air for. So that's my first goal. I'm going to find that time. Once I know that time, I know how fast the bullet is moving relative to the ground, doing a little relative velocity problem, so I can figure out how far it's going to fly in total from where the bullet started to where it actually impacted that second tank. I'm going to call that x total. During that time of flight, the first tank is going to move at 15 meters per second for that total time of flight, and the second tank is going to move at 35 meters per second times that time of flight t to give me how far that second tank moves. And so this little distance over here I'm going to call 15t, and this little distance over here I'm going to call 35t. And so you can start to see that if I take x total and I subtract off that 35t, I'm going to be left with x1. Or if I take that x total and I subtract off this 15t here, I'm going to be left with x2. So that's kind of my strategy. So setting up in the y direction. So in the y direction, I got y naught y, v naught y, vy, ay, and t. So I'm saying that it's starting and ending at the same height. So these are both 0. That means these things are going to be the same, just in opposite directions. So we had our 250 sine 10, and we had our negative 250 sine 10. Just because it's starting and ending at the same height, I can make that flip there on the sign. The acceleration is negative 9.8 meters per second squared, and you can go ahead and solve for time. I chose to use equation number 1 here, and so I ended up with a time of 8.86 seconds. So that is now the time that I'm going to use to find this distance, and find this x total. All right, so to find x total, all right, so we have x naught, x, v naught, x, vx, ax, and t. So during this flight time, it's going to move some distance we'll call x total. It's moving at a constant speed in the x direction. That speed is what we have to figure out. So we're going to have to set up our relative velocity problem. So the tank is moving at 15 meters per second. So that is the velocity of my frame of reference relative to the ground. Plus, I have to add on the velocity of my shell relative to the tank. So that's going to be my 250 cosine of 10. That will give me the velocity of the shell relative to the ground. Okay, so if I add that all together, that will tell me what number I need to put in here. Did I actually calculate a number? I did not. So my x total in this case, so this is just 15 plus 250 cosine of 10, is going to be 15 plus 250 cosine of 10, all times that time of 8.86 seconds. That gave me a total distance, which they didn't ask me for. We haven't yet to find anything that they technically asked me for. This number came out to be 2,314. From this, I can start subtracting those little numbers to get my value. So again, to find my x1, my x1 is going to be my 2314 minus that 35t, which was 8.86 for my time. And so x1, the original distance came out to be 2004 meters apart. So it fired it with a 2 kilometer distance between them. That's pretty impressive. And then my x2 is going to be my x total minus that little 15 t over there. So 2314 minus 15 times 8.86. That gave me an x2. Now, a good check for myself is this one's moving faster. So what should happen to the distance between them as that time goes on? It should increase. So I see that it comes out to be 2181 meters, which is larger than my 2004. Makes sense. You can do this a number of different ways, like I said, and you can be very creative with this problem because of some of the cool things you can do. So hopefully you got those same answers.